Okay, now that we know the different properties of equality, we're going to start using them and applying them to solve equations. So again, this is Math 0028, and we're going to talk about solving equations. This is still Module 3. And Section 2.1 in the ebook. Whoops, I'm sorry, 2.2 in the ebook is we're going to be talking about solving equations. Again, remember now, with equations we solve, with expressions we simplify. Equations always have an equal sign, right? And we're looking for a number that will make the equation true. So the first type of equations that we're going to solve, we're going to call this a one-step solution, one-step equation. And the reason we're going to call it one step is because we're only going to apply one of the properties, and within one fell swoop we'll be able to figure out the solution. And then we're going to eventually build on things that might require a few more steps. Okay, so one-step equations. And the goal for for solving any kind of equation, right, the goal is always to get the variable by itself on one side of the equal sign. So it'll always be something like, x equals whatever. Okay? So that is always our goal. So let's take an example. I'm going to say solve this equation. X minus 5 equals 4. So many of you can probably do this in your heads, but there's a very systematic way of doing it, right? So my goal is to get this variable by itself, right? Here's my x, so I want that x by itself. The problem is I'm subtracting 5 with it, right? I don't want to do that. So somehow I need to get rid of this minus 5. Well, if I use my addition property of equality, if I add 5 to this, which is the opposite operation as subtract, right? If I add 5 to this side, it goes to 0. So I'm just going to write plus 5 on the bottom down here, right? It used to be minus, so now I'm going to add 5 to it. So what I do to one side of the equal sign, I have to do to the other side. And I like to write this vertically because now I see this minus 5 and this plus 5 go away. They cancel out to be 0. And now I have x on one side with nothing else there. And that equals 4 plus 5, which is 9. And I can always check this. I can say does, when I plug in, I have x minus 5 equals 4. So if I plug in 9 for x minus 5, does that equal 4? And sure enough, 4 equals 4. So I know I have the right answer, right? And what I did here was I added 5 to both sides. So here's my solution, right? The cool thing about equations is you can always check your answer. So on a test, there's really no reason for you to ever get it wrong because you can always plug it back in to see if you got the right thing. Okay, let's try another one. Here I say solve b plus 8 equals 12. Sorry, equals, let's make it equals negative 12. Okay, so I'm going to ask myself, how do I get b by itself now? Right? Well, it's not on one side of the equal sign by itself yet. It's got that 8 there with it. And what I did was I'm adding 8 to b, So if I want to get rid of that 8, I have to subtract 8 from it, that side. If I do that, I have to subtract 8 from this side. Right? So now my plus 8 minus 8 goes away. And I'm left with simply my b by itself, which was my goal. And I have minus 12, negative 12 minus 8, where b equals negative 20. Right, again, I can check. Right, I have b plus 8 equals negative 12. So I'm going to stick negative 20 in there. And I'm going to ask myself, does that equal negative 12? Well, sure enough, it does, right? Negative 20 plus 8 is like negative $20 in the bank, and you add 8 to it, you're still in the hole. It's negative 12 equals negative 12. And I got the right answer, right? So in this case, I subtracted 8 from both sides, right? So I use the subtraction property of equality. All right, another example is, in this case, I have 12x equals 60. Well, what's the operation that we see in between the 12 and the x? We know that's a multiplication, right? But we still want to get this x by itself. That's still my goal. So since I'm multiplying by 12, I'm going to do the opposite operation again. So I'm going to divide both sides by 12. Then I get 12 over 12x equals 60 over 12, right? 12 over 12 is simply 1, so I get x by itself here, and I say x equals 5. Again, I can check. Right, my original problem was 12 times x equals 60. So I'll say, does 12 times 5, does that equal 60? 60 equals 60. And yes, I got the same answer, right? So in this case, I used the division property of equality. And I divided 12 on both sides. Okay, let's do one more example here. If I have, let's see, if I say solve x divided by 5 equals negative 8. Again, I want to get x by itself, and here what am I doing? I'm taking x and I'm dividing it by 5. So what do you think I need to do? I need to do the opposite operation of division, which is multiplication. So now if I multiply 5 on both sides, and again, it's always on both sides of that equal sign, right? This is the same as 5 over 1, so my 5's cancel, and I'm left with x equals negative 40. And again, I can check it. Right, I can say negative 40, well, I have x over 5 equals negative 8. That's my original. So if I say negative 40 over 5, does that equal 8? Does that equal negative 8? And sure enough, it does. So I know I came up with the right solution. Okay, so these are one-step equations. If you notice, it only took one thing. We either added one thing, subtracted, multiplied, or divided. And in one step, we were able to isolate our variable and get our answer. Okay, in the next video, we're going to go through problems that might require a few more steps. And basically, it's the same. You're still using the same properties, but you're just going to have a couple more steps.